Hey guys, welcome to day 10 of Intellipaat's Python week. So in the last session we looked into Python packages. So now we're going to look into multiple projects. In this session we're going to look into a Python project where we're looking into handwritten digit recognition. So before moving on to this session, please subscribe to our channel so that you don't miss our upcoming videos, and also leave a like if you enjoy our content. Now before moving on to this session, let's take a quick glance at the agenda of this session. So we'll start off with by understanding what exactly is handwritten digit recognition. Once we understand that, we look into the components of this project, that is, what are the components which make this project come together, and after that we look into the classification model which is used in this project. Moving ahead, we'll be looking into the GUI or the graphical user interface which makes this project work. And finally, we'll be looking into the complete hands-on which makes this project work. So that was the first one. So now we'll be looking into data manipulation with pandas. And then we'll be doing some data visualization using the matplotlib library. And finally, we'll be looking into some machine learning algorithms using the scikit-learn package. So now, without any further delays, let's begin with this session.
Welcome to this session on Python handwritten digit recognition project. In this session, we'll build a handwritten digit recognition project using Python. Now, this project is going to contain two components and we'll discuss what these are in a moment. But basically, it will be a project in which you will be building a model and a graphical user interface. We'll take care of how to do both of these, and we'll try and show you how you can deploy a real world working model into an application in this project. In this project, we'll also make use of a lot of technologies and we'll show you how to use them completely from scratch. The prerequisites for working along with this project in this video is going to be that you need to know a little bit of Python, TensorFlow, Keras, and NumPy and all the other libraries that are necessary for working with machine learning, deep learning models, and so on. Even if you don't know these, don't worry. Just stick with us till the end. Maybe you'll get to know all of these things as we are beginning completely from scratch. We'll also use Python and build a graphical user interface using it. So you need to know Python as well. And there are certain libraries that we'll be using along the way. So with that, let's begin by taking a look at what is handwritten digit recognition. So handwritten digit recognition is used to analyze and understand images or of digits that are handwritten by people and be able to recognize which digit is it. So if you've ever come across something called OCR, optical character recognition, handwritten digit recognition is something similar. OCR is a really important technology, but it took a lot of time for us to build the OCR technology. Here what we'll be doing is we'll be using a handwritten digit recognition. Now to do that, we need access to data, and we'll be using the MNIST dataset. Don't worry if you don't have access to the dataset. I'll show you how you can gain access to that as well. The important aspect here is that when you are writing something on a piece of paper and you show it to a computer, before deep learning was possible, it was really difficult for the computers to make sense what the data inside the digit is. It would very well understand that this is an image, what kind of colors are there in each pixel, and how to represent this and transfer this information from one computer to another. However, it was all like a black box. It understood how to display it, but our systems were not able to recognize what kind of data is present inside an image. If it's text or numerical, how to extract that data, all of that was just not possible. With the help of deep learning, we are now able to train machine learning models that can do this heavy working task for us. This is one of the most important aspects of deep learning, is that we don't have to handwrite the code that needs to do this kind of heavy work. We don't have to write the conditions and loops and all of that. We don't need to know what these are to train the model, but the model will take a look at the information that we have, which is labeled data, and it will be able to classify patterns and figure out how it can classify digits based on what the content of the image is. Don't worry if this sounds a little bit abstract. Stick with us till the hands-on, where we'll be building the model from scratch, and you can take a look at how it works. So with that, let's take a look at the components of the project. In this project, or in this handwritten digit recognition project, there are two major components. First is the classification model, and second is the graphical user interface. Classification model is the model that will be performing the classification part, which is it will take the image and tell us what is the digit that is contained inside the image. Second one is the graphical user interface. This is the interface using which we'll be building our own handwritten digit recognition system. This interface is what is going to be there between the user and the model. So user is going to interact with this, take the image, push it to the model will return the result, and that result will be displayed on the screen. And we'll combine these two things as well so that they work in tandem with each other. But before that, let's take a look at these one by one. Firstly, the classification model. Now, a classification model, in case you are not aware, is a model that is used to classify. In our case, we will be using it to classify the images of the handwritten digit into one of the 10 digits or one of the 10 labels, 0 to 9. So all the user is able to do as of now is draw a symbol that represents either 0 to 9, and any one of those numbers could be represented inside that image. And then our job is to classify it and tell the user what they have written. Now, this may seem trivial, but if you know anything about traditional programming, you know that this is really, really difficult to do. So in cases like this, we make use of classification models because it makes this task trivially easy, as we'll see in a few moments. Now, for this to work, we'll be building a deep learning model using Keras and TensorFlow. Deep learning makes use of neural networks. So in case you've never worked with deep learning or neural networks, you can take a look at this tutorial and understand how this works. If you're someone who has never built a machine learning or data science model, don't worry. We'll guide you through the code entirely. However, there may be some aspects of the code that seem a bit esoteric to you because you have never written a deep learning code. Don't worry, it's not to worry at all, but you need to understand how things are working, and we'll try explaining it as much as possible. For this, we'll be using Keras and TensorFlow. These are the two libraries that we are going to use in order to generate the model. Keras and TensorFlow are really important libraries when it comes to building deep learning models, especially in Python. However, you don't need to install them or configure it on your system. We'll even give you a way in which you can use it without installing anything on your system, and it'll work just fine. Now let's take a look at the graphical user interface part. This is the part that the user will interact with. So a graphical user interface or GUI will be connected to the model when a user draws a digit on the given canvas. We can use that digit to make the classification. So the user will be given a canvas on which the user can draw something. When the user draws that thing, we can then push that image back to the user, back to the model, and the model will take care of classifying that image for us. So with that, let's take a look at what else. So for this, we'll be using tkinter. Tkinter is a user interface creation tool that allows us to write code that can create the user interface for our code. This will be used for building the graphical user interface, and it is a very popular GUI library in Python. There are many other libraries available as well for building the graphical user interface. However, tkinter is the most popular one. It's very easy to use, and it's a library that has been used for a long period of time by many developers. So it's been around for a long period of time. It has been battle tested. Any bugs or code that you come across are going to be very rare. So we recommend that you use that as well. Finally, let's take a look at the hands-on. In the hands-on, we'll be building the model first. Then we'll take a look at how we can build the graphical user interface, and then we'll connect the two. So let's take a look at how we can do that. The building of the model part of our entire project. The first thing that we have to do here is we have to build a deep learning model. Now there are several ways to do so. One way of doing so would be to install the deep learning packages in your own system. These will be TensorFlow and Keras, and then train the model on your own system by using a Jupyter notebook or simple Python scripts as well. This depends on how you wish to build your entire system. I would recommend that you don't install these libraries and train it on your own. However, you can use another library or another platform rather to do exactly this. This is Google's Collaboratory or Google Colab for short. Now, you don't need to use this platform only. There are many other platforms such as Kaggle and all, but I would recommend that you make use of this because it's very easy to use. All the files that you create will be stored on your Google Drive, and you can make use of it as much as you can. Now, to use this, the first thing you have to do is go to the URL of collab.research.google.com. Make sure that you have signed in beforehand, and let me just go out of this. As soon as you log in, you will get this. It is the welcome page on the Google Collaboratory. You can download this code here. This is just an introduction. However, what else you can do is you can click on the file menu here, click on new notebook, and it will open up a new notebook folder. This notebook will be connected to a cloud computing server on the Google Cloud platform, and then you can use it with that. So I already have it connected and created, so I'll just close this one out. Yes, I will need this. I have it connected. As you can see, the RAM and disk are the things that I'm being shown. This is the current session. I can terminate it and create a new session. Now, just to show you that it works, I'll just write some Python code. And if I run this, as you can see, the output of the code is being shown here. So it's very similar to the Jupyter notebook that we have been using. It's just backed by a Google Cloud platform. Now, if you have a Jupyter notebook on your own system and you want to just connect it with this user interface, this is also possible. There are many other things that you can do. We won't be covering all of them. So the main reason why I want you to use this over your existing setups in your system is because this already contains all the libraries that you will need in order to use. So for instance, if you want to use TensorFlow, Keras, NumPy, Pandas, whatever library you want to use, you don't have to install anything here. This will all be installed already on the system that you wish to use. All you need to do is just write the code and then make sure that it runs. That's all you need to do. The configuration part is already taken care of for you. So let's just import the libraries that we want to import. The first thing that we want to import is Keras itself. Now from Keras, there are going to be several libraries that we want to install. First thing is going to be from keras.datasets. And as you can see, we get auto completion. I want to import MNIST. MNIST is the name of the dataset that we'll be using. Let me just show you what it looks like. When you search for it, as you can see, there's a handwritten digit database on this website. You can take a look at the images first to understand what the images will look like. And this is what it looks like. So it's a grayscaled image. Everything here inside the box is one digit, and it contains 28 by 28 pixels image data, ranging from 0 to 255. 0 meaning that the pixel is completely black, 255 meaning the pixel is completely lit up, so completely white. So as you can see, first row has 0 all the way, second has 0 and that way, and when we reach somewhere around 5 to 10, we start getting some white pixels. This is all arranged in a single list, and this is how it works. So this is what the images will look like once we make use of them. So we'll import that. The second thing that we have to import is the sequential model. So again, from keras.models import EQUEN sequential, and you can make use of the code completion hints that are given by Google Collaboratory. With sequential model, now we need to import the layers. So from keras.layers import, and from here we'll import everything that we need to import. We start by importing the dense, dropout, and flatten layers. So let's write them. Dense, dropout, flatten, and of course there are other layers as well that we need to import, such as the 2D convolutional layer and max pooling 2D layer. Con 2D and max pooling. Max pooling 2D will be the one that we'll be importing. And finally, that's about it what we need to enter. Finally, we'll run the cell. To run the cell, hold down the shift button and press enter. This is how you run the cell. Each one of these rectangular boxes in which we write the code is called a cell in a Jupyter notebook. The extension of a Jupyter notebook file is IPYNB, which stands for Iron Python Notebook. Now that we have installed everything, let us load the dataset, the MNIST dataset that we want to. This will give us two tuples. Inside the first tuple, we will get the training data, and inside the next tuple, we'll get the testing data. So we'll just get the xtrain and ytrain. These are the training data for x and y variables. X is the image data, y are the labels. Similarly, we'll go x test, y test, and we'll use the mnist dot load data function. I run this. This will work pretty fast, and as you can see, it is done. Let me just show you what the X test looks like. These are the images. We get array of arrays, and these are the arrays that we get. Similarly, we can also get y test, and you run the code. And as you can see, these are labels ranging from 0 to 9. So the first image is supposed to contain the number 7, then we have 2, then we have 1, and the last three are 4, 5, and 6. The data type is unsigned integer of 8. The data type doesn't really matter, but these are the kinds of things that we have to make sure that we understand. The X variable contains the image data, the Y variable contains the label that we want to make the prediction on. After this, let's take a look at the shape of the data. So we'll just print it just to understand how much data do we have. I think I forgot to print X. Okay, so we have 60,000 images. All of them are of the shape 28 by 28. Similarly, if you want to take a look at the X test, TEST, and you run this, you will take a look at 1,000 images. So we have 60,000 images for training and 10,000 images for testing. Now that we have gotten that, let's take a look at how we can reshape the data into something that we can work with. So let's do this. We will have xtrain and xtest, and we'll have to reshape it. Xtrain, and since it is given to us by MNIST.load data, which comes from Keras, we can call several methods on it. So we want to reshape it into a shape of 28 by 28 and by 1. So this is how we're going to make use of it. The first thing we have to do is type xtrain.shape 0. So we want to convert it from that to the shape that we want to convert it to, and for that all we have to do is type in the shape, which is going to be 28 by 28 by 1. Let's see if this works, and if it works, then we'll have to just do the same thing for training data set. So this is done, training is done. Now let's take a look at the testing data. Test, and again we have to do basically the same thing. So we run the code, it should work, and it does work. So we have gotten the data that we wanted to get, we have reshaped it. Finally, we need to define an input shape, 28 by 28 by 1, and we have gotten that as well. Now let's take a look at how we can use the ytrain and ytest one. So we have values here, we need to convert them into categorical values since they are going to be labels. So let's just do this. Ytrain is equals to ytrain dot categorical, and you can when you are trying to create the categorical variables, instead of using the categorical function, you have to use two categorical, and this will convert the numerical input into the categorical variable so that our input can be understood by the entire data set. So we have to use it. Oh yeah, I forgot. It is supposed to be keras.utils dot to categorical. So spelling is correct. Now here we have to pass in the data and the number of labels that we want. So this is just part of pre-processing the data. So if you have ever worked with machine learning models, you have to pre-process some of the data and make use of the data that you already have. So when we run this, this works fine, and we have reshaped the data and created a categorical variables as well. Now what we need to do is, after reshaping the data to categorical, we need to convert the training and testing data into float type. Float is more better understood by the entire machine learning process. So we'll convert it into a float type. To convert it into a float type, firstly we'll convert the xtrain data to float type. To do this, we have to type xtrain.as type, and inside the type we need to give a string that represents the type we want. So we want float 32. Similarly, we want xtest to have the same thing. So we train, we remove it and move it to test, and we do the same thing here. After doing this, we want to make sure that the pixels are in range from 25. So xtrain is equals to x 10 divided by 255. So 255 is the number of values that it ranges from 0 to 255. 255 means completely white, 0 means completely black, and everything in between is going to be shades of that. Again, this may seem a little strange to do, so using Python we can just change it to this. Similarly, we have to do the same thing for x test as well. Now xtrain is done, xtest is done, and now finally all we have to do is run the code, and this works as well. And now we need to create the model training pipeline. To do so, firstly we need to define some variables. These variables will describe how our model training process will go. The first one is going to be the batch size. Batch size describes BATCH. Batch size will describe how many images will it take for one single batch of processing. That it will make it understand how we can use it better. So 128 is the batch size. Then we'll tell it the number of classes that it's going to classify this into. Number of classes are going to be 10 because we are going to classify it from 0 to 9, and 0 to 9 are going to be 10 distinct values. Finally, we need to define epochs. Epochs means how many times are we going to run the training process. The more number of epochs means more number of times the training process is going to run, and the more number of times the training process is going to run, the more number of times we are going to get, the better accuracy we're going to get. However, it's going to take a lot more time to train. Now, let's take a look at how we can build the model. So to do though, we have to firstly create a model. Our model is going to be the sequential model that we have taken a look at. Sequential model means each layer is going to be executing after the next layer. Now we need to add a few layers. So I'll just write the code to write it. So model dot add. Inside it, the first one is going to be a convolutional layer of 2D convolution. As we have already imported it, we're just going to use this. Inside it, I have to write the shape of the convolution and the filters and kernels and so on. So we need 32 pixels. With the 32 pixel, we need the kernel size to be, let's see, kernel size. The kernel size is going to be 5 by 5. And convolution is basically a small filter or small array is going to rotate on top of everything. And we're trying to figure out some pattern in each of these small subsections of the entire image. This is where you can use your entire artillery of knowledge, and we can also change the structure of the entire model if you wish to. If it's not giving you a good result, then you can change that as well. Now let's determine an activation function. For this one, I'm going to use ReLU. You can use any function that you want, but the ReLU is considered to be better in this case. Finally, we need the input shape, and we have already defined the size of the input shape here, so we don't have to worry about that. There you go. So the input shape is given. Now we need to add another layer, and to do so, we just have to write model.add. Inside the model, I'm going to add a max pooling 2D layer. So max pooling 2D is already imported. That's why we're getting this code completion. And all we have to do is give it a size of the pool. So pool size is going to be 2 by 2. So this is how it's going to take a look at it. It's going to create a 2 by 2 matrix, going to convolve over all the pixels and going to take the maximum value in all of those four cells that it has with a 2 by 2 size. Now again, we are going to create a convolutional layer. So we have to write the same thing that we have written thus far. Model dot add con 2D. Inside it, we are supposed to not write all the things that we have written thus far. We're just supposed to write 64 as the filter size, then 3,3 as the filter size, and finally we have to write the activation function. Activation is going to be ready. We move ahead using this. After this, we are going to write the after writing the convolutional layer, max pooling layer, then convolutional layer. Again, we're going to write the max pooling layer. It's going to be exactly the same that we have written thus far. So I'll just copy it here, paste it here. And finally, I'm going to add another model. In this model, I'm going to add a flattening layer. So that will make our data easier to work with. Since we have already imported it, that's why it was at the top of our suggestion. After this, I'll add a dense layer. Dense layer is going to be added the same way we have added the convolutional layers. Model dot add a dense layer. Inside the dense layer, we're going to type the size of the dense layer. 128 pixels are going to be there, and we want the activation to be ReLU. So we've done that. So now that we have added the flattening layer, we have added the dense layer. Now we need to add a dropout layer, and it's going to be of the dropout convergency of 0.3. So model dot add dropout, and all I have to do is pass in the rate, which is going to be 0.3. You can read more about these layers when you're writing them, as you can take a look at the documentation, which is provided right into the notebook. So you can take a look at that as well. Now let's add another dense layer. This time it's not going to be the same as the one that we have written. We're going to make a few changes, not a lot. The first thing is, instead of it having 128 as the first parameter, we're going to pass 64. And the activation is always going to be redo. And finally, we are going to add another dropout layer. And in the dropout layer, instead of 0.3, we're going to have 0.5. Finally, instead of doing this, now we are supposed to add another dense layer, but the final dense layer will convert the shape to the size that we want to convert it to. Since we have 10 number of classes, I'm going to write num classes, and we'll have it 10. And finally, activation function here is going to change from ReLU to softmax. Run this. Let's take a look at it. I think we've run into some issue. Unexpected end of file while parsing. So it means that we have forgotten a brace or a parenthesis, and now it works. So that was a syntax error. Now we have gotten the syntax error out of the way. So model.compile is going to be our next process. In the compilation process, it's going to take all the layers that we have created and generate a model out of it, which we can then fit to train. So now we need to just tell it some parameters so that it can understand what we want it to do. The first thing is loss. How is it going to calculate the loss? Loss basically means how far away is it from the result, how accurate or inaccurate is it. So for the loss or accuracy function, we're going to use the categorical cross entropy function. So for this, all I have to do is use keras dot losses dot, and here we'll get a list of all the crosses, but here we'll be using the categorical cross entropy function to make the entire process easy for us to use. Now after this, we need to use an optimizer. Again, there are many other optimizers that you can use. Let's just take a look at this. Optimizer is going to be keras dot, and since keras is there, we don't need to code out these optimizers ourselves. They are already available for us to use. Keras is really important, that's why. And we are going to use the ADA delta. There are others such as Adam, AdaMax, AdaGrade, and all others. So you can take a look at this. And now finally we'll use the metrics. The metrics are going to be determining how we're calculating, or what is the thing that we're going to be calculating in order to calculate whether we're doing well or not. It's going to be accuracy. However, you can have many other things there as well. Now that we have gotten the accuracy here as well, let's run this. It runs, it works completely fine. So we didn't make any error in the syntax. Finally, let's just fit the model. So for that, all I have to do is type model dot fit, and that's how we're going to use it. Now model.fit, as you may or may not know, takes in the, let me just type it and it will show you, and it takes in the data. So the data that we want to fit it on is the training data, and then we use the things that we have already taken a look at. So firstly, let's type the training data, which is the x train, y train, given x and y. We have to type the batch size, which is 128, but since we have already written the batch size, it's there. Epochs is going to be the number of epochs that we have already written. And now the epochs are done. We are supposed to configure a few other things. Verbosity is going to be 1, and we need to pass in the validation data as well. So Verbose basically means what is the level of output we want. We want everything that has been written, everything that's going on underneath the model training process, or you just want to see a progress plot. So we want all the data that is available to us.
So you've learned a lot, right? So now let's look into a quiz and please try to answer it in the comment section or in the live chat. Now, what is the correct syntax to output hello world in Python? A echo hello world, then echo parenthesis quotations hello world, print parenthesis quotation hello world, or print square brackets and quotations and hello world. So choose the right answer, put the answers in the comment section.
Finally, we want the validation data, and that will be a tuple inside which we will pass in the x test and y test, which is our validation data. Now we run this. Okay, we run into an error. Oh, yeah, X-ray. Now we run this, and this is how the model training process is going to go. This will take a little bit of time, so we're going to pause the video now, and when the training process is complete, we'll show you how you can make use of the model then. So let's take a look at that. Now that our model is trained, we now need to save the model and use it in our own system, where we'll be developing the graphical user interface. Now to do so, firstly, let's take a look at the model. It took 10 training steps to train it entirely. The accuracy that we've gotten is 54% right now. This was just to show you how you can do it. In case you want to make the model more accurate, uh, raise the number of epochs from 10 to 20, 25, 30, 45, whatever it takes. It's also worth noting that when the versions of TensorFlow changes or Keras changes, these training process is going to yield different results as comes to accuracy. So when we have this, now we need to just save the model here. And to save the model, all we have to do is write the model dot or model dot, and we can use the save method on the model. Inside it, we need to type the name of the model. The name of the model could be anything. I'm going to call it model dot h5. You can call it anything that you want. You can also call it MNIST dot h5. Run this, and after running this, as you can see that we have this tab here. We open it up, we get MNIST.h5. Now you can click here, download the file. It will download it. I already have it downloaded, so it may not show you the same name, but it's going to download. So it's downloaded now. Every model that we wanted to use is now downloaded, and now we can make use of this model in our graphical user interface. So let's take a look at how we can do that. Alright guys, now it's time to write our graphical user interface. For that, we have already downloaded the model that we needed to use. We have used the MNIST.h5 extension, and the name of the model is MNIST. Now, to do this, you can use any code editor that you want to use, any libraries that you want to use. Firstly, let me just show you how I'm going to do this. So I open this up. Now, there are certain libraries that you need to install. So to install this, use pip install, and then type the name of the libraries separated by spaces. So the first library that I need you to install is Keras. Then, firstly install TensorFlow, then install Keras. Then you can install another library called pywin32. Pywin32, in case you are not aware, pywin32 is a library that is going to make it easy for us to interact with the Windows 32 graphical user interface system. If you're working with Windows, if you're working with Mac and Linux, there could be other similar libraries as well. But right now, our focus is on to make it work on Windows. You can also do platform detection using the operating system package that already comes with Python, and you can make sure that you are using it for the correct platform. In case it's not available for the platform that you're using, you can just show a method saying this is not available for the platform that you're about to use. And now, after installing this, you also need to install Pillow, which is an image manipulation library, a very sophisticated one that you can take a look at here. Finally, after this, you have to use, or you can make use of NumPy. NumPy is going to be used to translate and transform the image data into from a vector to a matrix and so on. Reshaping the data is going to be there. Now, I already have these packages installed, so I'm not going to do that, but this is the command that you need to run in order to install all these packages. Do bear in mind that TensorFlow is going to take a lot of time because it's a huge package. I think it's around 310 megabytes. And to install it, or after installing it, you can open up the code editor. I'm using Visual Studio Code, so I'll just open it up using the command line. Any code editor that you want to use is going to be fine. Just make sure it saves no formatting information. Now, if you take a look at the MNIST data, I click here. This is something that's stored in a binary format, so you won't be able to understand what's inside it. If I open it anyway, it's going to show me this, and it makes no sense. So now that that is done, I need to create a new file. I'm going to call it app.py or Python. After that this is done, let me just collapse the sidebar, and this is the thing that we have. Now for the graphical user interface, we're going to be using tkinter. This is already something that we can use with the Python tools. This comes installed for us, so we don't need to make use of any other graphical user interface system. Do make sure that you understand that the graphical user interface system that we're using here is just the front end. You can also deploy this model in a backend web service, for which you can create a front end with React.js or any other kind of thing. This is not necessarily the only way to do it, but this is a preferred way because we are writing all our code in Python. Now let's write the code. Firstly, let's import from Keras, import a function called load model. If you remember, we have already saved the model and we have copied it into the folder where we have created app.py. So this is the function that will help us load the model. Once we have loaded the model, now we can, from tkinter, we can import a few things. And don't worry if you don't understand them right now, I'll show you in a moment. So main loop and w. What these are not something that you should be concerned about. You can make use of it here, or you can also use from tkinter import star. That way you have imported everything that you needed to import. Now after this we can import tkinter, the entire package itself. So import, and inside the import statement we're going to import tkinter as tk. Now again, this is just a convention. You can choose to import it in some other way as well. Now we will import Win32 GUI. GUI stands for graphical user interface, and this is what we'll be using. This is unexpected end of file. So let's see. Import stuff. Yeah, it will work. I think there's some error with the Python extension. It's analyzing some things in the background, so it will work in a moment. Yeah, it will work. Now we have to make sure that we can access the image. So from PIL, which is the Python image library, which is now renamed to Pillow, we will import a few things. First one is going to be called image grab. So IMAGEGRAB. Second thing is going to be just the image constructor. That is going to be useful there as well. And finally, the image operations. So IMAGEOPS. Make sure that you are taking care of writing the capitalizations as I have written here. You are writing I capitalized, O capitalized, and everything in between. It should be written exactly as I have written. No messing up of the commas, and the capitalization of the letters is going to be tolerated because Python is going to throw an error. Now we need to import NumPy as well. So for that, I'll just import NumPy as NP. Say this, it works. Let's see if we've run into some actual errors. So I'll just write py app.py and run, and it's loading the TensorFlow library and everything as well. If you run into this error, this means that you have not set up a TensorFlow GPU backend in the system, which is fine. It doesn't really matter that you need to import it. If you can, if you don't want to, but it doesn't really matter that much. Now let's take a look at this. Okay, we've run into an error. Cannot import load model from Keras. Okay, take a look at this. That's because we have to write Keras dot models. Now it should work. Run this again, and it should run without any error. So in case you have not set up a TensorFlow GPU backend, this may show you this kind of warning. It's fine. We're not using a GPU based system and we didn't run into any error, so we have imported everything successfully. In case you run into some errors, you may need to rerun the installation commands that I have shown you at the beginning of, or at the beginning of this GUI coding session. So make sure that you do that. Now let's load the model. I'll just load it inside a model is equals to load model, and in the load model I'll type in the name of the model. Here it's MNIST.h5. Now that the model is loaded, I can use it to make the classifications and make the predictions. To do this, let's just create a function with that predict, or you can also call it make prediction. It will take in an image and it will return a classification label and the accuracy. Now after getting the image, firstly we need to resize the image. So image is equals to image dot resize 28 by 28. After resizing the image, we need to convert it into a grayscale image. As we have already seen in the MNIST dataset, when we're training the model, the data is going to be converted into a grayscale image. To do that, all we have to do is use the convert method inside our IMG. So to convert it to grayscale, you can take a look at this in the documentation as well. We use the L, we need to pass in a string that says L. So now after this, we need to create a numpy array of the image. So all we have to do is image is equals to np dot array and image. And the reason why we convert it into grayscale is firstly because that's how the model is trained, and secondly, this will convert the image data from 0 to 255. There might be some outliers, and we'll take a look at that in a moment. Now we need to reshape the data. To do so, img.reshape and pass in the shape 28, 28, 1. So after this, we get one array of size 28 by 28 by 1. We have reshaped the data as well. And finally, we need to make sure that all the data is in the range. So we just divide it by 255.0. And now the data is divided into what we need for it to work with. Now that we have done that, we need to make the predictions. And this is going to be really easy. All we have to do is use the result, which is going to be equal to model dot, and we have the predict method on it. And inside the predict method, we need to pass in an array of the image. So we pass in the image and we get the result. This result is also going to be an array, but since we want the first one, I'll just assign it to that. And finally, we need to return the numpy dot, and the argmax function is going to return the index of the number that has the highest value. So we have the result. This result is going to be an array of 10 values. Whichever one has the highest probability of being, that will be returned. And finally, we are going to be returning the max of result. So the value and the label associated with it are going to be returned here. Once we have returned all of that, that means we have returned the accuracy and the label and the accuracy in that order. Now let's create the application's graphical user interface. Now this is going to be inheriting from tk inter, from tk.tk. After importing it, since we have imported tk inter as tk, we can do this. We have imported everything that we needed to import, and we have inherited the class. Now the first thing we have to do is create a constructor. So def underscore underscore init underscore underscore and write in self. Inside it, we want the tk.tk, which is going to be the class that tk is going to use, and we're going to call its constructor. This is just a necessary step to configure the tk inter graphical user interface properly, and we need to pass in the self, and it's done. So now we have bootstrapped our tk inter process. Now let's create x and y. So what is going to be the coordinate? Let's see. Self.x is going to be self.y. Make sure that you're typing the spelling of self correctly, and all of this is equal to 0. So we're going to start from here, the top left corner. Then we're going to create a canvas. To do so, all I have to do is write self.canvas, canvas, canvas is equal to, and we need to create a canvas using tk.canvas. Canvas is going to be where we're going to be able to draw everything that we wish to draw. So here all we need to do is pass in the reference to the current frame. We can specify a width and height and the background. So width and height are all going to be 300.
Just a quick info, guys. Intellipaat provides online Python certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
You can maybe reshape it if you wish to, but it works fine. And then background is going to be WHIT. So we have width, which is equal to 300, height, which is equals to 300, background, which is white, and we can also write cursor. So see what's the problem here. I think I have, instead of using a comma, I used a full stop. Okay, and now cursor is going to be cross. This will change the cursor from being this pointer that you see on the screen. Yeah, right now you see this white pointer on the screen, which is the default, and it's going to change it into a cross, which will communicate to the user that you can draw something here. So now that we have changed the cursor as well, let's create a label, classification button, and a clear button. So for the label, all I have to do is use self.label is equals to, and again, as we have done earlier, we need to instantiate a label from the tkinter class. Inside the label, we need to pass in reference to the master frame. Here it's this, or the self. Then we need to pass in some text and font information. So text is going to be the default text for draw a digit for the label. And finally, the font information is going to be a tuple. Tuple is going to contain two things. The first thing is going to be the name of the font. Second thing is going to be its size. Again, you can play around with it. Helvetica is going to be what I use, but you can use anything that you wish to. Helvetica is just a choice that I'm making. The spelling is incorrect here as far as I'm aware. The spelling of Helvetica is Helvetica. Now for the size, I'm going to choose 48. Again, this is just pure speculation. If the size turns out to be larger than I want it to be, I can shrink it down as well. Also, if I have a Photoshop mockup of the entire design, I can just follow with that. But right now I don't, so I'm going to use this. Now I'm going to create two buttons. So let me just do that. Self dot two buttons are going to perform the task of classification and clearing. So classification button is going to be equal to tk.button button. Inside it, again, the master is going to be self, and here we can pass in a few options. First thing is going to be text. Now the text is basically just what we want for the text to show. Here we're going to type it classify, or you can also call it recognize, but I'm going to call it classify. And then finally, the last one is going to be the command. Now command is going to take a function. So I think it's going to be called classify handwriting. I've not made the function yet. I'll make it. Classify and writing. This function needs to be created. I'll create it in a moment. Let me just create it here. Def classify handwriting self. And right now there's nothing there, so I'll just call it path. Similarly, I have to create the clear button. So I'll just write clear button. This will again take the same parameters as it did earlier. I have written button. I'll call it clear and clear. That's it. So now that we have created the graphical user interface, now we need to place them on the grid itself. So we need to create a grid, or a grid is by implicitly created on a graphical user interface surface, and we need to place these things on the grid. So to do that, all I'll have to do is, let me just resave this, self dot canvas dot grid, and the grid is going to the grid in our case is going to take row, column, padding on the y-axis, and some other parameters. So let's see. So the row is going to be 0, column is going to be 0, Padding on the y-axis is going to be 0. So we don't want any margins or paddings here. And sticky is going to be w. So the sticky here is going to show us how is it going to stay within the frame or is it going to spill out. So we want it to stay in the frame. So we have done that as well. Now that that is done, we need the label, the classification button, and the clear button as well. So the label is also going to be part of the 0th row, and we're going to do the same thing. So let's do this. Instead of canvas, we're going to now add label. So 0th row, but the column is going to be 1. Now that we have added the label as well, we need to add the padding y and padding x. Earlier the padding y was 0, here padding y is going to be 2, and padding x is going to be 2 as well. Let me just make sure everything works. Done. Yeah, so everything looks the way it's supposed to. Now that grid is done, now the other two things that we need to add are the classification button and the clear button. And the classification button and the clear button are going to be used the same way that we have used grid. So the label is there. Now let's add classification button. It needs to be on row 1, column 1, and the padding X and padding Y are going to remain the same. Finally, we need the clear button. So for that, clear button is going to be row 1, but the column is going to be 0. I'm sorry, 0. And after this, when we have added 0 to the column, we just need the padding Y to be 2, and everything else we don't need. Now finally, what happens when the person is dragging their mouse through the canvas? How do we want it to draw things on the canvas? This is what happens when we are going to use the self.canvas.bind method. To do this, we'll write self.canvas.bind. Inside the bind, we need to firstly write in the sequence, and this is going to show what action do we need to perform on what event. So the event is going to be v1 motion, which means using the mouse when the user is drawing on the canvas, what we want to do. v1 motion is there, and we want to call the function self.draw. Now that that is done, we are done with writing everything that we needed to write. And now finally we have to use the methods that we have defined here. First one is draw, second is clear, third is classify handwriting. So let me just see. Yeah, so it's matching. Now let's write this. So to do that, firstly let's get the canvas information. So we go to self canvas dot, and in the canvas there are several methods. The method we're interested in is windows info, and inside the windows info we just want the ID. So win info underscore ID. This is a method, and it will return the identifier for this object or this widget. Once we've gotten the identifier, now we need to create get the coordinates or the rectangle that is bounding this canvas. So to do this, I'll just write rectangle, which is going to be equal to, and this rectangle is going to be equal to the win32 GUI that we have imported, and we're going to get the get window rectangle. So it will give us the coordinates of the canvas, and since we have already gotten the hardware identifiers, we have gotten that. Now we'll use our image grab function to grab the image. So going to be image grab, and using this. So what happens is now our Python code is going to take a look at the coordinates and going to get the image that is on the coordinates that we have provided. After getting the image, what we need to do now is again the same thing that we had done earlier: convert it, invert it, and then convert it again. So to convert it, all I have to do is image is equals to im dot convert l, im is equals to im dot invert. This is to convert the image into a grayscale image. White colors will be converted to black, and black will be converted to white. Or not this way. I have to make sure that image grab dot invert image. Now that we have inverted the image, we need to convert it to make sure that everything's working, and this is the final step in which we make sure that everything is converted the way it's supposed to. Now that we have converted the image, we make the prediction, get the digit and accuracy. So digit comma accuracy is going to be, and the function that we had created earlier was make prediction. So make prediction, inside the prediction we pass in the image, and now that we have gotten that, all we need to do is put the text that we have gotten into the label. So for that, I have to write self dot label dot, and inside the label we need to configure it. So config, and here is where we're going to set the text. So to set the text, all I have to do is firstly make sure that text is there. Convert the label that you have gotten into a string. I've called it digit. You can call it anything that you want to. Now we need to concatenate a string to make sure that we are passing it correctly. So adding a comma, and then after getting the accuracy as well, we need to firstly convert the accuracy to integer and multiply it by 100, because the accuracy is in a range from 0 to 1. So we'll just do that, accuracy multiplied by 100. Once we get the 100 part, we are to convert it to integer. After this, we are to convert it into a string, because the label is going to be a string. And finally, we are supposed to add a percentage here, just to make sure that the user understands that this is the percentage that it gets. So classify handwriting is done. Now we need to write the draw lines method and clear all method. Let me just write the clear all method first, or clear method. Takes in self, and what it will do is just delete everything on the canvas. To do so, we'll just write self dot canvas dot delete. And what do we want to delete? We want to delete everything. Now the method that we had binded over, we use the draw function here, and for the draw function, all we need to do is we need to pass in the self and the event. Self event. Now here's where we're going to perform our code. So we need to pass in the x and y and radius. So self dot x is equals to, and the x we're going to get is from the event. Similarly, self dot y is going to be event dot y, and radius is going to be 8. If you want to draw more thicker lines, then you can change 8 to 16 or some other number as well. And now we need to just make sure that we are drawing the line. So self dot canvas dot, and inside the canvas we are going to create an oval. I'll show you why in a moment. Create oval is going to take in a few parameters. First one is going to be x, second one is going to be y, third one is going to be r, fourth one is going to be the x, y coordinates in the top right, top left, top bottom corners, and finally we'll fill in the color. So for that to work, we need to pass in self dot x minus r, y minus r. This is the top left and top right corner. After we have reduced the radius, then we're going to write self dot x plus r, self dot y plus r, and we need to pass in the keyword self correctly. Now that that is done, all we need to do is specify the color. I want the color to be black, so that when it's inverted it becomes white. Black. That's done. Color is converted to black as well. Now finally we need to make sure that we have instantiated the app. The name of the class is app, so we can convert it. All we need to do now is just make sure that we have indented it properly, which we haven't in this case. Okay, and then use the main loop function. This will run the tkinter loop and make sure that the program doesn't end unless the person has clicked the close button on the top left corner. So with that, it should work just fine. I think we've run into an issue here. I think I didn't write np.reshape or img.reshape. Now it will work. So now comes the moment of truth. Let's see if our code is working. So py manage.py, py app.py.
Hey guys, let's take a look at another question. So how do you start writing a for loop in Python? So A for x and y, for x greater than y, and C for each x in y. So put down the right answer in the comment section or in the live chat.
Enter, and it is going to connect to the backend right now. TensorFlow is going to boot up the TensorFlow package. Now it's going to connect to the backend. It's going to make sure everything runs. I think we run into an error. Oh yeah, tkinter has no attribute tk. That is because the k is supposed to be small. Now let's run this again. It's going to take a little bit of time to boot the entire system again, and again we ran into an error, and it's the same error that we had earlier. It's on the line 61, so we'll just go and fix that. Let's just check where we have written tk capitalized. It's supposed to be smallest. Say this, go back, refresh, go back and run the code. And right now let's hope that it works. If there's any other error, that will catch it as soon as we can. So again, it boots up everything, tries to run, and another error. It has no attribute called clear. Okay, let's take a look at the error where we're getting it. Okay, I understand. We have no attribute named clear here, and that is because the method does have an attribute named clear. Let's see what the error is actually about. tkinter tkapp has no object or attribute named clear. Let's mean just maybe there's a problem with the code and just rename it from clear. No, yeah, that is the problem. We need to now actually there was an indentation problem. Again, it's going to connect to everything that we wanted to connect to. So TensorFlow is booting up again, and we're running into the same issue of not having the TensorFlow GPU in the backend. It's okay, we're not using the backend, and now we have the GUI with us. Now let's use it to see if everything is working or not. Alright, now let's see how it works. So if I were to draw an image, click on classify. Okay, we've run into an error. Let me just close this up. As you can see, the GUI was still working. Okay, so we have the error in the code, and okay, so here, oh, instead of image grab, I should have used image ops. Clear that up, run the code again. This time it should work. Let it boot up. It will start in a few moments. So it connected to the TensorFlow backend. Let me just see if this works. Click on classify, and as you can see, our classification is working. Again, yeah, the accuracy is here, the number is here. You can use any other number from 0 to 9 and it should work. If you want to clear it up, you can click on the clear button. The label is still going to be there. You can make sure that you can change it later on, and you can close it, and the code is going to close here as well. So that is it for the tutorial. We hope you enjoyed the tutorial. We hope you learned what you needed to learn here. So we've come to the end of the entire project session. Hopefully this has been informative. Hopefully you've learned how to use TensorFlow, how to use Python to create a graphical user interface, and how you can connect the two.
Consider yourself to be data scientist at a prestigious telecom company, and the name of that company is Neo. And they are facing a major problem, and that basically is their customers are churning out to other competitors. Now, you as a data scientist at that particular company have to make sure to stop this churning out, and also how to find out the reasons why customers are churning out to other companies. Right, so this is the problem statement, and what you're basically going to do is a bit of data manipulation, data visualization operations, and then you'll go ahead and build the ML algorithms on top of this data set. You'll start off with the linear regression algorithm, and then you'll build the logistic regression, decision tree, and random forest algorithms. All right. And we'll be working with this customer churn dataset. So this is our dataset which comprises of all of these columns. So we've got customer ID, gender, senior citizen, partner, dependents, and so on, right? So yeah, so this is our first task, data manipulation. And to do this, let's go ahead and actually import all of our libraries. So I'll just type in import pandas as pd, and then I'll also load the numpy library. So I'll type in import numpy as np. I'd also need the matplotlib library. So I'll type in from matplotlib import pyplot as plt. So these are all of my required libraries. I'll just wait till these libraries are loaded. Right, this is done. Now I'll also go ahead and load up my customer churn data frame, and I'll store it into an object and name that object to be equal to customer churn. I'll just use pd.read underscore csv. And inside this, I will give in the name of the data frame, which is customer churn.csv. Right, so I have successfully loaded the file and I've stored it into a new object, and also I've named that new object to be equal to customer churn. Now I'll go ahead and have a glance at the head of this. So customer churn dot head, and this is the dataset on which we'll be implementing all of the operations. So this is just the unique customer ID. This column gender tells us about the gender of the customer, whether the customer is male or female. The senior citizen column tells us whether the customer is a senior citizen or not. So if it's 0, then the customer is not a senior citizen. If it's 1, then the customer is a senior citizen. And then this tells us if the customer has a partner or not. This tells us if the customer has dependents or not. This is the tenure of the customer in months, right? So 1 month, 34 months, 2 months, and so on. This tells us if the customer has phone service or not. Does the customer have multiple lines? And this is the type of internet service used. And then whether the customer has online security, whether he has device protection, tech support, streaming TV, streaming movies, and so on. And then this column is for contract. So this just tells you the contract type of the customer. So the contract type of the customer could either be month to month, 1 year, or 2 year. And there's a type of billing, whether it is paperless or not. After this, we have the type of payment method. So the type of payment method could be these: electronic check, mail check, bank transfer, and so on. And then these are the monthly charges and total charges incurred by the customer. Right. So now let's start off with our data manipulation tasks. So this is our very simple task. We just have to extract some individual columns from the entire data frame. We'll have to extract the fifth column and store it in customer 5. So let me do that. I'll type in the name of the data frame first, which is customer churn, and I would use .ilog. I would need all of the rows, and I would need the fifth column since the indexing starts from 0. So 0, 1, 2, 3, and 4, right? So this would be my fifth column over here. And I will store this in, let's say, C underscore 5. And I'll have a glance at the head of this, C underscore 5 dot head. Right, so we have successfully extracted the fifth column from this entire data frame, and this is the head of it. Similarly, we'll have to extract the 15th column and store it in customer 15, right? So if it's the 15th column, then the index number would be 14, because again, the indexing starts from 0, right? I'll store this in C underscore 15, and I'll also make this to be C underscore 15. I'll click on run, right? So this is the streaming movies column, and I get the same thing over here. This is column number 15, and I've extracted only this particular column from the entire data frame. Right. This was basic extraction of columns from the entire data frame. After that, we'd have to do data extraction on the basis of a condition. We'll have to extract all the male senior citizens whose payment method is electronic check. Right. So there are 3 conditions over here. The first condition is the gender of the customer needs to be male. Second condition is senior citizen, the value of senior citizen needs to be equal to 1. And the third condition is the payment method needs to be equal to electronic check. So I'll give in all of these three conditions over here. I'll start off by giving the first condition, customer churn. I'll type in gender, and the gender needs to be equal to male, right? I'll cut this and paste this inside this. Of this, I'll use the AND operator and then given the second condition. So the second condition would go something like this, customer churn. After this, we'd have to set the senior citizen value. Right, so senior citizen, this needs to be equal to 1. And then I'll go ahead and give in the third condition. So over here, the third condition, this is for the payment method column. So the payment method needs to be equal to electronic check. All right. So I have all of my three conditions over here. I'll just paste a cell below. Now, what I'll do is I will copy all of these three conditions and I will paste them inside this, and I will store it into a new object and name that object to be crandom, right? Now I will print the head of this, crandom.head. So we see that so if you have a glance at this gender column, then you'll notice that all of the values are male. Similarly, if you have a glance at the senior citizen column, then all of these values are 1. Similarly, I'll go to the payment method column, then you'll notice that all of these values are electronic check. So I've given three conditions over here, and all of these conditions have been satisfied. So next up, we'd have to extract all of those customers whose tenure is greater than 70 or their monthly charges is greater than $100. Okay, again, we'll do the same thing. Customer churn, tenure needs to be greater than 70. I'll put this up inside this. Now, what you need to notice over here is we are using the OR operator. So it's either the first condition or the second condition, right? So if one of these conditions is true, then we'll get that particular record. So again, customer churn, and this time it's the monthly charges. So the monthly charges have to be greater than 100. These are the two conditions. So either the tenure of the customer needs to be greater than 70 months, or the monthly charges of the customer needs to be greater than $100. Again, I'll insert a cell below, and all I'll do is cut this and paste it inside this. Right. And I will store this in, again, crandom. Now let me again print the head of this, crandom.head. Right, now I'll head on to the tenure column. Now you see that none of the tenure or none of the values of the tenure over here is greater than 70. But if I go to the monthly charges column, then you'll notice that the monthly charges are greater than 100. So it's either or. So one of these conditions has to be true. And in this case, we see that the second condition is true over here, right? So if either of the condition is true, then we'll get that entire record. After this, we'd have to extract all those customers whose contract is of 2 years, payment method is mail check, and value of churn is ES. Right. I'll again copy this, paste this over here. Let me delete this from this. Right, so we have these conditions over here. So we'd have to extract those customers where contract is of 2 years, payment method is mail check, and churn is equal to yes. So let me put in all of these conditions over here. First is contract, and this needs to be equal to 2 years. So let me just check, how is it? Contract is of 2 year, right? 2 space year. After that, it's the second condition, and over here the payment method needs to be equal to mailed check. Again, I'll put in the double equal to operator, and I'll give in the value, and the value is equal to mail check, and then I'll give in the final condition over here. So customer churn, and this time the churn needs to be equal to yes, right? So I've given all of these three conditions and I've separated them using the AND operator. Again, I will store this in C underscore random. Let me print this out, C underscore random. So we see that there are just three records, or there are just three customers who satisfy all of these three conditions. So let me have a look at the contract of this, right? So contract is of 2 years for all of these three customers. Next is the payment method, and again payment method is mail check and churn. All of these values are yes, right? So out of all of those 7,000 rows, only there are three rows which satisfy these three conditions. Next, this is a question on random sampling. So we just have to extract 333 random records from the entire data frame. And to do this, we'll be using the sample function. So I'll type in customer churn and I'll use the sample method over here. And inside this, what I'll do is I'll give the value of the number of records which I want to sample. So I want 333 records. I'll store this in C underscore 333. Let me print out the head of it. Right, so now what I'll do is, so whenever I run this, every time I'll get a different sample of 333 records. I'll run this again, right? So if you have a glance over here, so all of these values would be changing, the customer IDs would be changing, the indexes would be changing, right? So keep a glance or have a glance at these row IDs indexes over here, right? So again, if you have a glance at this, the row IDs are changing. So this is random sampling. I'm randomly sampling 333 records from this entire data frame over here. And I'm doing that with the help of the sample method. Right, and then this is the final operation when it comes to data manipulation. So I'd have to get the count of different levels from the churn column. So if I want to get the count of the different levels present in a categorical column, I have the value counts method. So first I'll give in the name of the data frame, which is customer churn. After that, I'll give in the name of the column, which is churn. And then I'll just type in value counts, right? So this is it. So let me just wait till I get the result, right? So we see that no, so the number of customers who will not be churning out is 5,174, and the number of customers who will be churning out is 1,869. So you can do the same thing for other categorical columns as well. So let's say if I want to get the count values or the number of counts of different levels for, let's say, the contract column, I'll just change the name of the column over here. So I'll put it to be equal to contract, right? So there are 3,875 customers whose contract type is of month to month. There are 1,695 customers whose contract is of 2 years, and there are 1,473 customers whose contract is of 1 year. Right, so these were some basic data manipulation operations. After that, we'll head on to data visualization. All right. So here we'll have to create a simple bar plot for the internet service column. And yeah, we'll have to set the x-axis label to categories of internet service, y-axis label to count of categories, the title of the plot, distribution of internet service, and the color of the bars need to be equal to orange. Right. So I'll just type in plt dot bar over here. Now I'll insert another cell over here. Now what I'll actually do is, so this basically takes in two parameters first. So the first parameter is the names of all of the bars, and the second parameter is the values for those bars, right? So the names of the bars would be coming from the internet service column. So internet service, and I actually want the value counts of this. Value counts, and from this I don't want the values, I just need the keys. And again I'd have to convert them into a list. So I'll use list over here. Now I'll click on run. Let's see what do we get, right? So these are the three levels present in the internet service column. So from this internet service column, what I've done is I've used the value counts method. So this value counts method has two things, keys and values. Now I don't want the values as such, I just want the keys, and I'll take these keys and I'll convert these keys into a list, right? So this is the list of the names present in this internet service column. Now I'll cut this and paste it over here, and this would be my first parameter, and my second parameter would be all of the values. And if I want all of the values, I'll just remove the method keys from there, right? So this over here would give me all of the values present with respect to this internet service column, right? So fiber optic, or in other words, the number of customers whose internet service is fiber optic is 3096. Number of customers whose internet service is DSL is 2421. And number of customers who don't avail the internet service are 1526. Right? Now again, I'll cut this and I'll paste it over here. Now let me print this out. So this is my basic bar plot over here, right? So this is my bar plot. On the x-axis, I have the names representing these bars over here, right? So this bar is for all of the customers whose internet service is fiber optic. This is for those customers whose internet service is DSL, and this is for those customers who are not availing the internet service. And these are their counts over here, present on the y-axis. Now, I had to do some other things over here. I had to change the color of the bars. So the color of the bars was supposed to be set to orange. And for this, I have the color parameter, and I'll just set it to be equal to orange. I'll run this again, right? So we have successfully changed the color of these bars over here. Now I'd have to set the x-axis label and the y-axis label. So I'll just type in plt.xlabel, and the X label needs to be equal to categories of internet service. Let me type that down. Categories of internet service. After that, I would need to put in the label for the y-axis. This would be plt.y label, and I'll just put it to be equal to count. And then finally, I'd have to give in the title. So plt dot title, and I'll set the title over here, and the title needs to be equal to distribution of internet service. Let me type that out. Distribution of internet service. I'll click on run, right? So this is our final bar plot, which gives us the distribution of internet service, and the x-axis label is categories of internet service, and the y-axis label is count. Right, so this is how we can create a simple bar plot, and all of this. So these are the basic steps behind before you go ahead and build all of your machine learning algorithms. So the pre-processing, the data pre-processing part is always the main part of your data science life cycle. So this is where you properly comprehend your data set. This is where you understand the structure of the data set. You understand the correlation between all of the columns, the correlation between the dependent variable and the independent variable. So by manipulating the data set and visualizing the structure of the data set, this is where you understand all of the patterns in the data set and you get insights from the data set. Right, so next up we have to build a histogram for the tenure column. So again, it'll be a similar operation, plt.hist, and I'd have to build a histogram for the tenure column. So it'll be customer churn tenure, and I'd have to set the number of bins to be equal to 30, and I'd have to set the color to be equal to green. So I'll just type in color equals green over here. So this is our histogram, and this gives us the distribution of the tenure of the customers. So Yep, so if you look at it closely, so this is basically the count over here, right? So there are around 800 odd customers whose tenure is not even 1 month. So they are churning out before they even complete 1 month. And again, there's a huge peak over here. So there are around more than 600 customers whose tenure is 70 months or more than 70 months. And then rest is pretty much the same, right? So the average customer, yeah, so this is the normal range of the customer. So it's between 200 to 400. And the average tenure of the customer, you can say, would be somewhere between 20 months to 50 months or 60 months, right? And this is where you have the peak. So you have the peak at the starting and you have the peak at the ending. Again, let's go ahead and add the title. So it'll be just plt dot title over here. And the title of the plot needs to be equal to distribution of tenure. I'll do that. Alright, so I have created this plot and this is the title of the plot, which is distribution of tenure. So we've made a bar plot, we've made a histogram. Now you guys also need to understand the difference between a bar plot and a histogram. So a bar plot is normally used for all of the categorical columns. So whenever you want to understand the distribution of categorical columns, that is when you'll go with a bar plot. And when you want to understand the distribution of a continuous numerical column, that is when you'll go with a histogram. Right, so next up, we'd have to create a scatter plot between monthly charges and tenure. So tenure is on x-axis and the monthly charges is on y-axis. So plt dot scatter, x-axis would be tenure, so customer churn, tenure, and then I'll set in the column for the y-axis. This will be customer churn and this will be equal to monthly charges. Let me just run this, right? So this is what we get over here. Now let me also set in the labels for this. So plt dot x label and this would be equal to tenure. Let me type in tenure over here. Similarly, I'll also set the y label over here. So this will be plt dot y label and this would be equal to monthly charges. Right, so now we also get the corresponding x and y axis labels. After this, I'll also go ahead and set the title. So it'll be plt dot title and this would be monthly charges versus tenure. Monthly charges versus tenure. Right, so this is our final scatter plot where we have the x-axis and y-axis labels, and this is the title, which is monthly charges versus tenure. Right. And finally, we'd have to also build a box plot between the tenure column and the contract column. So tenure needs to be on the y-axis and contract needs to be on the x-axis. For this, I'll just type in customer churn dot box plot and so now I'll set in this to be equal to customer churn contract, and after this I have the column to be equal to customer churn and this needs to be equal to tenure. Let's see what is the error over here. Column is not found. So let me actually remove this from over here and let's see what happens. Alright, so now we get the result. So we had actually given the name of the data frame initially itself. So it was customer churn dot box plot. And now all you have to do is assign the contract onto the x-axis. So now when I said by equals to contract, what is happening is I'll have one box plot each for the different levels of the contract column. So I have one box plot for the month to month level. I have another box plot for the 1 year level and another box plot for the 2 year level. And over here, the y-axis, this is being determined by the tenure column, right? So this over here, 0 to 70, this is the tenure of the customer. And what we understand from this box plot over here is, so if the contract of the customer is of 2 years, then most probably the median tenure of the customer is very high. So if the contract of the customer is of 2 years, then his tenure or median tenure would be around 65 months. Similarly, if the contract of the customer is 1 year, then the median tenure of the customer would be around 45 months. And then if the contract of the customer is month to month, then the median tenure of the customer would be around 15 odd months. Right, so these were all of the examples of visualization. Now it's finally time to head on to machine learning. Right, so this was your data pre-processing part, where you had understood the structure of the data. You had learned how to extract individual columns, and after that you learned how to visualize the data and get some interesting insights from the structure of the data.
So you've learned a lot, right? So now let's look into a quiz and please try to answer it in the comment section or in the live chat. Now, what is the correct syntax to output hello world in Python? A, echo hello world, then echo parenthesis quotations hello world, print parenthesis quotation hello world, or print square brackets and quotations and hello world. So choose the right answer, put the answers in the comment section.
We'll start off with our first machine learning algorithm, which would be linear regression over here. And linear regression, as you already know, so over here the dependent variable would be a numerical column, and you're basically trying to understand how does one variable change with respect to another variable. And over here we'd have to build a simple linear model where our dependent variable is monthly charges and the independent variable is equal to tenure.
Just a quick info, guys. Intellipaat provides online Python certification training mentored by industry experts, the course link of which is given in the description below. Now, let's continue with the session.
Right, so or in other words, we are basically trying to understand how does monthly charges vary with respect to tenure. So monthly charges, dependent variable, tenure is the independent variable. And these are all of the subsets when it comes to this linear model. So we'll start off by dividing the data set into 70-30 split, and then we'll build the model on the train set, pick the values on the test set. After that, we'd have to find out the root mean square error, and yep, we'd have to print out that root mean square error. So let me go ahead and import the linear regression model from sklearn. So I'll type in from sklearn import linear model. After this, I'll type in from sklearn dot linear model import I need linear regression, right? So these are my two basic libraries. So I needed linear model, I needed linear regression. Now I would also require the train test split. So I'll type in from sklearn dot model selection import train test split, right? So this train test split method would help me to divide my dataset into training and testing sets. So now it's time to divide my data into training and testing sets. So before that, I'd have to get my target and the features, or in other words, I'll have to separate my dependent variable and the independent variable. So monthly charges is the dependent variable. So what I'll do is y equals, and I'll extract only the monthly charges column, and I will store it in a new variable and name that variable to be equal to y. Similarly, I'll only extract the tenure column, right? So I'm extracting the monthly charges column and I'm storing it into a new object, naming that object to be equal to y. Similarly, I'm extracting only the tenure column and I'm storing that column into x. Run columns, customer churn. What seems to be the problem over here? Monthly charges. Let me put it to be capital C over here. Right. Now let me print out the head of these two, y dot head and x dot head. Right. So these are the values from monthly charges column and these are the values from the tenure column. Now let me go ahead and divide these two into training and testing sets. So I'll use in train test split. I'll pass in x as the first parameter. So all of the features would be which are stored in x go as the first parameter. After that, I'd have to give in the target labels, and the target labels are which are basically my monthly charges, which are stored in y. And then finally, I'd have to give in the test size. So let me check what was the test size. So the test size was supposed to be 0.70. And then I'll also set a random state. So if I want to use these values again, I can just set the random state to be equal to the same value which I'm giving over here. This is smallest over here, right? So this test size 0.70 basically means that 30% of the records would go into the testing set. Oh, this has to be 0.30. Sorry for that. Yeah. So 30% of the records would go into the test set, and 70%, the rest 70% of the records would go into the training set. Now I'll be getting 4 results over here, and those 4 results are xtrain, xtrain, ytrain, xtest, and ytest. These are actually the labels which we conventionally use. I'll explain what these are exactly. Xtrain, ytrain, and then we have so this would actually be xtest first, xtrain, xtest, ytrain, and ytest. So over here, xtrain represents all of the all of those values of your features which are present in the training set. Xtest represents all of the features which are present in the test set. Ytrain represents all of the dependent values which are present in the train set, and ytest represents all of the dependent values which are present in the test set. And whenever we are building a model, we'll build that model on top of the train set, right? So we'll build the model on top of xtrain and ytrain. Let me also show you the shape of all of these. So xtrain dot shape. Let me do the same for the rest. Xtrain dot shape. I'll make this to be ytrain. I'll make this to be xtest. And I'll make this to be ytest. Right. So xtrain, ytrain. So the training set has these many records, and the testing set has these many records over here, right? So these are all of the features which are present in the training set, and these are all of the features which are present in the. Sorry, these are all the features of your dependent variables, and these are all of the features of the independent variables, and these are all of the target values when it comes to the test set, and these are all of the target values when it comes to the your dependent variables. All right. So now that we have xtrain, ytrain, xtest, and ytest, let's go ahead and build the model on top of the training data. Now I will go ahead and create an. So normally your training data would be bigger because so let's say your splits are either 70-30, 65-30, or 80-20. Because the more data you give for training, that is better. But then again, you can't give out your entire data for the training set, right? So the purpose of training your model is to make sure that your model learns the underlying patterns of that data. And once the learning is done, you'd have to also test how well the learning is done, right? And to test, you'd also need a sample space for that test set. So consider this simple case. So let's say you're giving an exam, And but for that exam, let's say if you got 100 exercises, so your syllabus comprised of all of the 100 exercises, and you'd have to learn all of those 100 exercises. But when it comes to your test, it will have only 10 exercises from all of those 100 exercises, right? So the training needs to be done, but then again, the test space, it needs to be completely new, which is not learned by the model, during the training phase, right? That is why the training set has to be completely different and the test set has to be completely different. And the division of training and testing set is done to make sure that overfitting doesn't happen. And when overfitting happens, the problem is this model will perform well on this particular data set, but when a new data set comes in, it'll miserably fail, right? So this is the reason why we divide the data into training and testing set. Right, so now let me go ahead and create an instance of the linear regression model, and I'll name that to be regressor. So I've created an instance of linear regression over here, and I'll go ahead and fit the model on top of the training set. So it'll be X train and Y train. Right, so I fit the model on top of the training set. Now it's time to predict the values. So it'll be regressor dot predict, and I'll be predicting the values on top of the X test. And I will store this in, let's say, ypred. Now I've fit the model on top of the training set, and I've also predicted the values on top of the test set. Now I'd have to know how well the prediction has been done. And for this, when it comes to linear regression, we have something known as the root mean square error. So the lower the value of root mean square error, the better your model. And again, we have an inbuilt method to calculate the root mean square error. So I just have to import sklearn dot metrics, and from sklearn dot metrics I'd be importing mean square error. Now after this, so mean squared error, what we actually want is root mean squared error. So I would need the np dot square root, and let me use the mean squared error, and this takes in two parameters. First parameter comprised of the actual values which are present in y test, and second parameter are the predicted values which are present in ypred. So I will cut this, and let me ease this to be in this over here, right? So we get a root mean squared error value of 29.39. Right, so now let's say if you build some other model with some other independent variables. Now we'll go ahead and build the model, and we'll also predict the values. Now after predicting the values, we'll also have to calculate the root mean square error. So this root mean square error is actually relative. So let's say if there is some other model, let's say model 2, and the root mean square error of that model 2 is, let's say, 39, then this model would be better than the second model. Similarly, if there's, let's say, model 3 whose root mean square error is 19, then that model 3 would be better than this model which you built over here. So here we are predicting the monthly charges values. That is exactly right. So let me actually show you that. So let's see, I'll put in ypred, and let's say I'll have a glance at the first 5 values, right? So these are the monthly charges predicted. Let me also show you y test, then 5, right? So these are the actual values and these are the predicted values over here. Right. So this is not exactly dependent on the churn of the customer. So what we are doing is we are building an entire data science lifecycle process. So over here we are trying to understand the relationship between the tenure of the customer and the monthly charges of the customer, right? So over here, what we're basically trying to understand is, let's say if the tenure of the customer is at around 10 months, what would be his monthly charges? Again, if the tenure of the customer is 30 months, what would be his monthly charges? Similarly, if the tenure of the customer is 70 months, then what would be his monthly charges? So this is what we are trying to understand over here, right? So this time we'd have to build a logistic regression model where dependent variable is churn and independent variables are tenure and monthly charges. Again, I do the same thing. Let me actually copy these two. So this is what we did over here, Aditya, right? So this is where we went ahead and predicted the values, didn't we? Right? So I have divided my data set into training and testing set. And over here, I am fitting the model only on the train set, right? So training is happening on the training set, or the model is learning from the train set. And we are predicting the values on the test set. So this model, this linear regression model, has not yet seen all of the records present in the test set. It has only learned from the values which are present in the training set. So we'll go ahead and build the linear regression model now. Customer churn. Let me also put in Y. I'll do the same thing. So in the logistic regression model, our independent variable is monthly charges. Let me put monthly charges over here, and the logistic regression, sorry, the dependent variable is churn. So I have extracted or I have got my features and my target over here. So features are basically my monthly charges and my target is present in the churn column. And I'd want to understand if the customer would churn or not on the basis of the monthly charges of the customer, right? So I've done this, and the rest of the process would be the same over here. I'll go ahead and divide this data frame into train and test, right? So this is 65-35 ratio this time. So I'll set it to be 35. So this time 35% of the records would be present in the test set, and the rest 65% of the records would be present in the train set. And I'm storing all of those into xtrain, xtest, ytrain, and ytest. Right. After this, I'd have to import the logistic regression model. So from sklearn dot linear model, I'd have to import the logistic regression model, and I'd have to create an instance of this. So I'll name this to be equal to log model. All right, so I have created an instance of this, and I'll go ahead and fit the model on top of the training set. Right, the entire process when it comes to implementing this is pretty much the same, right? So Python makes it extremely easy. The sklearn library makes it extremely easy. All you have to do is take in the data, find out your independent variables and your dependent variable, and then go ahead and divide those target and features into training and testing set, build the model on top of the train set, and then break the values on top of the test set. And then you will find out the metrics. So for classification, it's confusion metrics and your normal accuracy score, and for linear regression, it could be either root mean square error, mean square error, or moving averages error. So log model dot fit, and I will fit this model on top of the training set again. So x train and y train, right? So I have fit the model. Yes, we can also have multiple independent variables, Sharadata. So again, so if we have a single independent variable, then that's that's a simple model. So when it comes to simple linear regression, we have a single independent variable. When it comes to multiple linear regression, you'll have multiple independent variables. Right, so this basically means that we are trying to understand how does our dependent variable change with respect to multiple independent variables over there. And so again, consider this equation. So linear regression equation is based on this. Let me actually open Notepad over here, right? So y equals, let's say, x1 plus x2 plus x3 plus x4. So what happens in a simple linear regression is you just have one independent variable, which would be x1. What happens in multiple linear regression is you have multiple independent variables, which are x2, x3, x4, and so on. Right? And you're trying to understand how does y vary with respect to all of these independent variables. That's pretty much it. Right, so let's proceed with this. We have built the model on top of the training set. Now let's go ahead and predict the values on top of the test set. So it'll be log model dot predict. So here we change the value of x, and no, we are not changing the value of x. We have multiple x values over here, right? So this becomes mx1 plus m2x2 plus m3x3 plus m4x4 and so on. We have multiple independent variables, and you are trying to understand how does y vary with those multiple independent variables. So log model dot predict, and I want to predict my values on top of the test set, and I'll store this in again y pred. Right, so we have predicted the values now. Right, so when it comes to a classification model, we can use the confusion metrics, right? So let me import the confusion metrics. So from sklearn.metrics, I will import the confusion metrics, also the accuracy score. Now let me find out both of this. I'll pass in the actual values and the predicted values. Actual values are present in y-test and predicted values are present in y-pred. Similarly, accuracy score, I'll do the same thing. Y-test and y-pred. Right, so this is our confusion matrix and this is the accuracy, right? So to get the accuracy, what you'll basically do is you'll divide the left diagonal with all of the values. So left diagonal represents all of your correctly predicted classifications. So this comprises of all of your true positives, right? So this part over here, this is all of your true positives and this is all of your true negatives, right? So when you divide this with the entire sample space, that is when you will get the accuracy. So let me do that. So that'll be 1815 divided by 1815 plus 651, and I get the same accuracy, which is 73.60, right? So I get an accuracy of 73% for the model which I've built. Now I'd have to build a multiple logistic regression model, or the dependent variable is the same and the independent variables are tenure and monthly charges. So now we have two independent variables, so I'll make the changes here itself, right? So Charada, the question which you're asking, what if we had multiple independent variables, right? So over here, we have two independent variables. So this time the independent variables are monthly charges and tenure. And I'm trying to understand whether the customer would churn or not on the basis of these two columns, which are monthly charges and tenure, right? So X now would comprise of these features and Y is the same. And the ratio is 80-20. So I'll change the test size to be equal to 20 over here. I'll go ahead and fit the model. It's the same. Again, I'll predict the values is the same, right? So I build the model. I predicted the values. The only difference which I made over here is I have two independent variables this time instead of a single independent variable, right? Predicting the values. After that, I'll import confusion metrics and accuracy score, right? Now over here, again, I'm calculating the confusion metrics and this time I get an accuracy of 77.50, right? So this time it'll be 935 plus 157 divided by 935 plus 157 plus 106 plus 211. Right? So we get an accuracy of 77.50. So this left diagonal are all of the values which have been correctly classified, and this right diagonal represents all of those values which have been misclassified. So this was logistic regression, and then we've got two more machine learning algorithms left, which are decision tree and random forest. So let's build these two. Right, so for decision tree, dependent variable is the same, which is churn, and independent variable is tenure. Right, so let me manually do this. X is customer churn, and the independent variable is tenure. Let me also extract the dependent variable. So the dependent variable would be churn. You have to make sure that you put in the spellings correct, and also you have to take care of the small caps and the capital letters over here. Right, now I will go ahead and also import the decision tree classifier. So from sklearn dot tree, I'll be importing the decision tree classifier. Now I'll go ahead and divide this data frame into train and test. So it'll be the same process. Let me copy this. Let me paste it over here. So the split is 80-20, which is what we are doing over here, right? So this is our feature, this is our target labels, and we have divided the dataset into training and testing set. Now let me go ahead and create an instance of this decision tree classifier. I'll name this instance to be, let's say, my tree, right? And I'll go ahead and fit the model on top of the training set. So my tree dot fit, this takes in two parameters, which are x train and y train. I fit the model. Now it's time to predict the values. My tree dot predict, and I'll be predicting on top of the x test. Now I'll import the metrics, right? So let me calculate the confusion metrics and also the accuracy score. Confusion metrics. So I'll actually have to store this in a object first. Again, I'll be storing this into ypred. Let me run the cell again. And this again takes in two parameters. First parameter is all of the actual values which are present in ytest, and all of the predicted values which are present in ypred. So this is our confusion matrix now. Let me calculate the accuracy, which would be 965 plus 87 divided by 965 plus 87 plus 281 plus 76. Right, so for this decision tree model, we get an accuracy of 74%. Right, so the process is entirely the same, guys. Right, what we are doing is, again, at the risk of being redundant, so what we are basically doing is finding out our features and target variable. After that, we are dividing the features and target into training and testing split, and then we'll go ahead and build the model on top of the train data, and then we'll predict the values on top of the test data. Once the prediction is done, we'll calculate the accuracy to find out how well our model has learned. Right, so in the entire data science life cycle, our most important part is the data processing part, right? So because to the model building the, so it depends on your problem statement, Aditya, right? So let's say if your dependence on your it depends on your problem statement and what exactly you're trying to find out. So let's say if your dependent variable is a continuous, if it's a continuous variable, if it's a continuous numerical, then you'll go with linear regression. And if you want, if you have multiple categories, right? So if you have multiple categories, then you'll go with either decision tree or random forest. So when it comes to logistic regression, it is a binary classifier. So let's say if you have just two labels in your dependent variable, like this case over here, right? So this is where you'll go with logistic regression. But then again, if you have multiple categories, or if it's a multi-classification problem, then you'll most probably go with decision tree and random forest. And again, when you compare decision tree and random forest is always better than decision tree, because random forest is an ensemble model. So again, through your course, you would have learned that a random forest is nothing but an ensemble of decision trees. And the accuracy or the prediction given by a random forest is better than a decision tree. So that you can actually take for granted, right? So whatever accuracy a decision tree gives, the accuracy given by a random forest is better. So just to verify that, let me actually go ahead and build a random forest model on this same data over here, right? So we'll take the same x and y values.
Hey guys, let's take a look at another question. So how do you start writing a for loop in Python? So A for x and y, for x greater than y, and C for each x in y. So put down the right answer in the comment section or in the live chat.
No, so again, problem statement was different, Aditya. So linear regression we use to understand how does monthly charges vary with tenure. But the other algorithms which we've built, that was to understand how does churn vary with other factors, right? So over there, monthly charges was a numerical column, but churn is a categorical column. So we can compare logistic regression and decision tree, right? So let's say if we compare logistic regression and decision tree, right? So logistic regression gives us an accuracy of 77%. Yes, yes, right. So logistic regression till now, yes, has given us the best accuracy, right? Right. So now finally, we'll also go ahead and build an ensemble model, which is random forest. So let's actually compare the accuracy given by this decision tree and the random forest. So from sklearn dot ensemble, I'll import the random forest classifier and I'll create an instance of this. Maybe I'll name this as RF and I'll just create an instance. Right. And I'll go ahead and fit the model on top of X train and Y train. X train and Y train, I fit the model. Now it's finally time to predict the value. So rf dot predict, and I am predicting the values on top of the X test. Let me build the confusion metrics over here. Right, now let me check the accuracy. So I'll just type in accuracy score and I'll pass in y test and y pred. Y test, y pred. So we get an accuracy of 74.66 and it's 74.66, right? So there's not much of a difference when you compare decision tree and random forest over here, right? So we've got the same values, right? But normally in general, if you're building a random forest model, so you'll either get a better accuracy or you'll get the same accuracy, right? So this is your normal entire data science life cycle. So you'll start off with the data pre-processing part, data exploration part, where you will understand the structure of the data set. You'll visualize the data set and understand whatever is happening underneath it. Right after that, once you understand and comprehend your data properly, that is when you'll go ahead and build your model. Again, when it comes to building your model, you will sort of follow the same procedure. You'll find out your independent variables and the dependent variable. Then you'll go ahead and divide those two into your training and testing set. You'll build the model on top of the training set, and then you'll break the values on top of the test set, and finally you'll calculate the accuracy. Right. So here, so this is your entire end-to-end project on the customer churn dataset, which comprise of data manipulation, data visualization, and implementing all of the machine learning algorithms.
Just a quick info, guys. Intellipaat provides online Python certification training mentored by industry experts, the course link of which is given in the description below.
Okay guys, that's it for this session. I hope this session was helpful and informative for you. If you have any queries, leave a comment down below. Or if you have any new suggestions for us to make as a video, please leave that also in the comment section down below. So thank you, meet you in another session.